Alright, so we're going to go ahead and jump into Module C. Module C is all about rational expressions. In this first section, we're going to talk about multiplying and dividing. This comes from section 6.1 of your textbook. Before we get into our rational expressions, let's start off by just recalling multiplying and dividing fractions. So let's go ahead and look at the fraction 4 over 9 times 3 over 10. Now remember that there are two ways you can do this. The first one is to multiply straight across and cancel, but the other method that we used was we canceled and then we multiplied. And so let's go ahead and do that. So what can we cancel? 3 and 9. We can cancel a 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. 4 and 10, we can cancel a 2. 4 divided by 2 is 2, and 10 divided by 2 is 5. So now the question is, what are these numbers here? What are they called? These are called common factors. And the key phrase there, the key word there is factors. So when we talk about simplifying rational expressions, that's going to be one of the key things that we're going to want to do. This is all going to revolve around factoring. In order to multiply rational expressions, the first thing that we want to do is factor each numerator and denominator completely. From there, we want to cancel factors that appear in a numerator and a denominator. Note, they can be in the same fractions or different fractions. Just has to be a top with a bottom. Once we are done canceling our common factors, we will multiply straight across. In this section and in most math classes, you may leave in factored form. You do not have to distribute or FOIL in order to simplify the numerator and or the denominator. All right, so let's go ahead and look at some examples. In our first example, we have x minus 3 over x plus 5 times 10x plus 50 over 7x minus 21. To start off with, my left fraction is going to stay the same. Nothing factors out from x minus 3, and nothing factors out from x plus 5, so those are going to stay the same. In my second fraction on the top, we can start by factoring out a 10. If we factor out a 10, inside we are going to be left with 10x divided by 10 is x, and 50 divided by 10 is 5. On the bottom, I can factor out a 7. So if we factor out a 7, we divide each term by 7. 7x divided by 7 is just going to be x, and minus 21 divided by 7 is going to be minus 3. All right, so now we can go ahead and cancel things that appear in the top and bottom. One thing to note is that you have to factor, or you have to cancel the whole x minus 3 and the whole x plus 5. So what can we cancel? I can cancel an x minus 3, and I can cancel an x plus 5. So what are we left with? The numerator, the only thing left is 10, And the denominator, the only thing left is 7. So our final answer is 10 over 7. All right, let's go ahead and look at example B. Example B, we have x minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. Again, the left fraction is going to stay the same. X minus 7 cannot be factored. Similarly, x minus 1 cannot be factored. So we'll leave those the same. On the right side, x squared minus 1 is difference of squares. X squared is x and x. Things that multiply to 1 is 1 and 1. And we have different signs. On the bottom, the only thing I can do is factor out a greatest common factor. I can factor out a 3. And if we factor out a 3, 3x divided by 3 is x. Negative 21 divided by 3 is negative 7. And I just realized I made a mistake. This should be x minus 7. Okay, so now what can we cancel? If you copied it correctly, you should be able to go ahead and cancel x minus 7s. And you can cancel x minus 1s. So now what is left over? In the top, we have x plus 1. In the bottom, we have a 3. So our final answer is x plus 1 over 3. All right, let's go ahead and look at some more challenging examples now. So a couple of things that I want to point out before we do this. Don't reinvent the wheel. You don't have to factor everything from scratch. Start with easy factorings. Look for GCF, difference of squares, leading coefficients of 1, etc., and use the results to help you factor other polynomials in the problem. Remember that ultimately, the goal is to multiply and simplify, meaning we should be able to cancel common factors. We are going to not only be able to cancel common factors, but we should be able to cancel more than one common factor. All right, so let's go ahead and see what we can do. Let's look at example C. Now, the first thing that I want to do, as we mentioned in the last presentation, is I want to flip my terms in the bottom so that this is in descending order, so that our negative 3x squared is first, and then our 6x. This will make it easier when we start doing our factorings. Okay, so now let's talk about, okay, what is easiest to factor? So for me, when I look at this, the first things that I always look for are greatest common factors. So if we look at the left side, on top, I do have a greatest common factor of 4. If we factor out a 4, 4x divided by 4 is x. 8 divided by 4 is 2. The bottom is also greatest common factor. And so I can factor out a negative 3. I can also factor out an x. And if we factor out that, negative 3x squared divided by negative 3x is x. And 6x divided by negative 3x is minus 2. All right. The next thing that I consider to be easiest to factor, the next easiest thing for me to factor, I think, is the bottom right. This is difference of squares. So if we factor this, 9x squared is going to be 3x and 3x. 4 is going to be 2 and 2. And we have different signs. Now, one thing, if you're kind of paying attention, is nothing's canceling so far. So we need to kind of keep in mind the top when we factor this. So if I want to do maximum cancellations, I want to choose factors from the bottom. Now, all of these, except for we're going to ignore the greatest common factor, x minus 2 and our 3x plus 2 minus 2, all of these could potentially be factors for the numerator. Now, to get maximum cancellations, I think x minus 2 is what I want to start with. Remember the whole purpose of this. We are trying to cancel things. We will do a quick check step to make sure that our factorization is correct. So if I go with x minus 2, we're going to go ahead and factor this. So 3x squared breaks down to x and 3x. And negative 4 breaks down to negative 2 and positive 2. If I do a quick check, I'm just going to check my outsides and my insides. My outsides, I get 2x. My insides, I get negative 6x. And does this combine to give me negative 4x? Yes, so this is correctly factored. Now that everything is factored, I can go ahead and do my cancellations. So what cancels? Well, I have an x minus 2 and an x minus 2. I also have 3x plus 2 and 3x plus 2. Those are the only things that are going to cancel. So now we want to write what is left over. In the numerator, we have 4 times x plus 2. In the denominator, we have negative 3x and 3x minus 2. Again, we can go ahead and leave in factored form, and so this here is our final answer. Okay, let's go ahead and look at example D. Now, D, we definitely want to take advantage of this rule of using what we have available and starting with easy factorizations to start. So if we go ahead and look at this, I want to know, what do you think is easiest to factor? For me, I think that the top right is easiest to factor. 5 is prime, negative 2 is prime, and so this is a level 1 factoring. So if we go ahead and factor this, 5x squared is 5x and x. We can go ahead and just try this, but to me 3 is a small number. I do not want to multiply 5 times 2, which means that I want them in the same set. So I'm going to put my 2 in my first, 1 in my second. So now I want to know, where do my signs go? We are multiplying to a negative 2, which means different signs. I want my larger quantity to be positive. So which one is larger? My outsides, 5x times 1, or my insides, 2 times x? Well, 5x times 1 is larger, so I'm going to put my plus sign with my 1, and I'm going to put my minus sign with my 2. If you do a quick check, we do get our outsides 5x minus our insides 2x is equal to 3x. So this is the correct factorization. Okay, from here, we're going to find that this kind of snowballs on itself. And so I want to know which one of these factors could be a factor for the denominator. I'm not going to look at x plus 1 just because technically x plus 1 could be a factor of anything. So I'm going to look at my 5x minus 2. Can it be a factor of the right side on the bottom? And the answer is no. 3x squared is not going to break it down into 5x times something. Well, what about the bottom left? Does 5x go into 10x squared? Yes. Does negative 2 go into negative 6? Yes. And so I'm going to take a shortcut, and I'm just going to say, well, let's see if it works. I'm going to let 5x minus 2 be the factor for the bottom left. So now if we break this down, 10x squared is going to be 5x times 2x. Negative 6 is going to be negative 2 times positive 3. If we do a quick check, my outsides minus and my insides, what do we get? My outsides, if I multiply this, I get 15x. My insides, I get negative 2 times 2x is negative 4x. Is that equal to 11x? Yes. So this is a correct factorization. Okay, so now let's repeat the process. Let's try to factor the top left. So again, I want to know do I have something here that could help me out? So 6x squared, does 2x go into 6x squared? It does. Does 3 go into negative 15? It does as well. So let's go ahead and try it. I'm just going to go ahead and let my first factor for the numerator be 2x plus 3. So now 6x squared breaks down to 2x and 3x. Negative 15 breaks down to positive 3 times negative 5. If we do a quick check, my outsides, I get 2x times negative 5 is negative 10x. My insides, I get 3 times 3x is plus 9x, which does simplify down to negative x. This is correctly factored. Okay, now what are the chances this is going to work again? So now we want to come down to the bottom right, and let's try 3x minus 5. 3x squared, does 3x go into 3x squared? Yes. Does negative 5 go into negative 20? The answer is also yes. So I'm going to go ahead and let 3x minus 5 be my first factor. So my second factor, we get 3x squared is 3x times x, and negative 20 is equal to negative 5 times positive 4. All right, quick check. If we do our outsides, 3x times 4 is 12x. Insides, we get negative 5 times x is negative 5x. And when we simplify this, we get 7x, which is what we wanted. So now everything is factored. Notice that if you start with easy factorings, you can kind of use this idea of canceling common factors to help you factor the rest of it. So finally, we want to go ahead and cancel common factors. What do we have in common? Well, I see a 2x plus 3. I see a 3x minus 5. And I see a 5x minus 2 appear in tops and bottoms of our fractions. So now what is left over? On top, I am left with x plus 1. On bottom, all I have left is x plus 4. And that takes care of multiplying rational expressions.